Dear students, I remember again, you must have a short abstract of each presentation and put it in a report and send the report to the PhD board, okay? Don't forget to pay attention to all presentations, okay?
Well, good afternoon, everybody. Everybody still having dessert? Or is it wine? Well, let me present you Smart MC2. We are a startup. A couple of years ago, we started to develop this project, and believe it or not, it was on the back of a challenge from a friend asking me, can you give me a smart meter so I don't have to go to my farm and actually read the readings. So at the time I had absolutely no idea that farmers actually needed smart meters and why. So everybody, thank you. So from that idea we started developing Smart MC2 or Smart MC Square as we like to call it, and you know why. It comes from Einstein energy. And in terms of what we do and what is our mission, which is very much aligned with what Sonia over there, Sonia, she's not looking at me, spoke in the morning in terms of environment, how do we save water, how do we actually do something for our farmers, how do we put technology on the ground, how do we leverage the technology that currently exists to make the farmers' quality of life much better. And that's one of the visions that we have, is to allow farmers to continue to produce, continue to do better, but have some quality of life. This pilot, or this project started with a company in Resende, where the farmer is very lazy, is a friend of mine, and his goal is actually to be able to control the farm from his bed. And you can do that at the moment. You can turn on irrigation, you can see what's going on his cherry farms without leaving his bed. Of course, on top of that, we have everything that is going on at the moment with the world. We need to save water, we need to measure the water that we are using, we need to actually start being more creative and more smart in the way that we use water. So the problem itself starts with this. And most people don't even realize the amount of water that is spent in agriculture. 70% of the water that we have available goes into farming. And I'll give you an example, it's a live example, and I'll show you that in a minute, where we have a customer, our current customer, the first one actually, that has 4.5 hectares of blueberries, 4.5 hectares of blueberries, and he spends in there daily 300 cubic meters of water. So you start understanding what that number means. If we all together actually get our water bill, we wouldn't be spending that in a month. He spends that in there daily. 4.5 hectares of water. So this project started exactly in terms of all the data that we collected. What can we do to save water and continue to produce everything that everybody likes in terms of apples, blueberries, strawberries, but without consuming the same resources that we currently are utilizing, which are 70% of the water that we have is going into farming. So what is the solution that we came up with? My apologies, I need my glasses. So basically we developed a software that currently is in the market. We developed several sensors with open source technology. We are not doing anything new. We are grabbing everything that already exists in the market. We are getting all the chips from several suppliers in China. We are bringing the firmware together, and we are putting together the hardware that goes in the field, and that's then all the data is collected into several platforms, open source as well, except our platform that is AgroFusion, that you'll see in a minute, that allows farmers to control and manage remotely, completely remotely, what's going on the ground. And I'll show you a few examples, one even from yesterday, where we detected a massive leak on a farm, where the farmer would be losing not only production, water, and we were able to help him identify that and act exactly on that specific problem. So we do it with AgroFusion. AgroFusion is linked to one of our sensors developed not by us, because the chip itself is available to anyone. We developed the firmware on top of it. In one single sensor, we can collect 11 different parameters from the ground and from the air. And those are, and I need to read them because they are too much, so moisture, temperature, nitrogen, phosphorus, potassium, pH, salinity, solid conductivity, and TDS. For those who don't know what TDS is dissolved metals in the water or in the ground, and then humidity and temperature on the air. There's much more that we collect. We can put in weather stations. We collect data from flow meters, so we understand what is the life, the organic life in a farm. We know when the water is coming out. We know where it's going, and we know if it is being used correctly or not. And then we look at that data, and we actually act on that data. And this is the funny thing. We can do actually irrigation, the smart irrigation, or what the ground actually tells you that you need. There is still a very long path to follow in terms of the farming, of how can they use that. Even now I was discussing with Batista, I have two customers, one with blueberries, one with apples at the moment. And both of them tell me that at this stage, they don't care about what is the moisture on the ground. They want water on the ground, they want more water on the ground. Who can tell me why? It's so simple as that. I understood that last year. They are paid by the weight. If they put more water on the plant, the fruit, the apple, the blueberry, will absorb more water, it will weigh more, and they are paid by the weight. So that's exactly that formula that we need to find a right balance for it. So what we do, we put sensors on the ground. Each sector, usually, and the case study that we have has 15 sectors. We have other farms with 35, 37 sensors or sectors of irrigation, and we measure exactly what is going on. We correlate the data from the ground, from the flow meters that are showing the water, that are flowing the water. That enables us to identify a lot of problems on the ground, from valves that are not closing, from pipes that are burst, from over-flooding in terms of farming. So it's a correlation of data from what they see on the ground, and most of the time they don't even see it, because if it is hot like it was last week, the farmer goes into the farm and he sees a dry ground on the top. But if he drills down 30 centimeters, there's enough moisture in there, but he doesn't see it. So we will put more water just to cover that. So AgroFusion, that I will show you very quickly in a minute, because I would be spending probably the rest of the afternoon with you on that. It's our software that collects data and just shows it and acts on the data. That's our main difference from what the market currently has. There's a lot of companies reading data, universities reading data, but no one is actually automating that into the ground. If I have moisture at this level, I should be turning off the water. In greenhouses, if I have this amount of moisture inside the greenhouse or this temperature, I should be opening the windows, and that can be completely automated with IoT. So in the end, basically, what we are looking for the farmer is a very good return on investment. Quality of life, one of the principles of our company is giving quality of life to the farmer, at the same time maintaining and increasing their return on investment by working with us. At the same time, when we developed this project, AgroFusion was developed in a way that is agnostic. So it doesn't know what data it gets. AgroFusion doesn't care if it is moisture, if it is temperature, if it is pH. Whatever data it gets, it can then be configured to act on that data. So it can actually be scaled to full sites, water storage units, residential buildings. So it doesn't matter what it's used, because we are just looking at data, and as long as we have the skills of the expertise, in this case we are working with farming, to tell us what to do with that data, then we can actually teach the software or configure the software to actually enact on that data. Why now? And I think that's more than obvious. We are in a crisis with water everywhere. People haven't realized yet that it is a finite resource, and in a few years we will struggle with that. So we actually need to act now and start actually not just implementing technology to help us with that, but at the same time start teaching not only farmers but everyone that water is a finite resource and we will struggle with it. I remember a few years ago seeing a movie where they were pointing at 2025, 26, that we would be limited to 6 bottles of water a day. That will come. That will come. And if we don't act, that will be much faster than that. So let's make this project what we are aiming to, and that's always sustainability, what everybody wants at the moment, what everybody talks in terms of how do we save water. Now, the market, I'll jump it very quickly because someone already told me that time is running out. Main partners that we work with, mainly are from China. We supply from China, where most of the hardware is. Regino is one of our main partners. TechLick from Canada, Milesight from China, HKT from China, Top from China. And then we started developing some very strong partnerships, and I like the one in the middle, UTAD. I was born there. But at the same time, we already have projects with ESA, in Companhia das Ilhas and Vila Viçosa, and with LUNEG. This is a funded project from the European community. We are starting to work with the Escola Superior Agrária de Viseu and the Escola de Tecnologia São Lamego, exactly on the same. So in this one it's pine trees and chestnut trees. In there is the cork. So we are analyzing, and it's a study that will last 4 years to analyze the montado in China. And we have a partnership as well with Geodoro, our parent company. We do what they don't do, they do what we don't do, and we link very well together. So we have started to work with that as well. Who are we? So I'm Miguel Cardoso. I just returned recently from the UK after 20 years there, where I made my professional life. And I returned to the Douro, which is my birthplace, and I want actually to do something for it. Luis Almeida with me, my commercial director. Harry Musgrove, my CTO and chief programmer, is the one that actually makes that happen. I tell him what to do and he does it. And then we have 2 major investors already, international investors, that started to put money into the company, Jit Keira and Tom Tipple from the UK, that liked the project, saw the value of it, and actually want to make money. That's, to be honest, what it is. And that's me. So just quickly showing you, and let me just move to my other screens. And as usual, now internet here is very slow, so it will take probably some time to upload. It is spinning. So this is the agrofusion. Oh, not showing. Oh, sorry. I need to win the presentation. Oh. So this is agrofusion working exactly on that blueberry farm that I spoke to you about in Guilheiro. Guilheiro, for those who don't know where it is, it's in Sernancelho. The owner of this farm lives in Resende. That's 2-hour drive to get there and another 2 hours to come back. He was going there every couple of days just to check if everything was working fine, if pumps were working, if everything was there. Currently, he only goes there if there is actually a problem, which actually happened yesterday, and I'll show you what we detected. So for those who don't understand what I'm showing on the graph, the second graph in there shows how it should be. So each sector turns on, and we see the water flowing, stopping, the water flowing, stopping, the water flowing, stopping. What happened yesterday, he had a problem with valve number 6. Valve number 6 never closed. That brings in two problems. One, that sector will continue to be watered. Second, the other sectors will not, because he hasn't got enough power in his pump to actually turn on more than one sector at a time. So he actually went there yesterday, replaced the pump, or replace the valve, and now this is the graph that shows me what happened tonight when the irrigation was running. Everything was on and we can control it remotely. We can even see what's going on, and that's what generated. Now, by looking at that, I spoke with him half an hour ago. I told him, you have another problem on valve 9. This valve should have created exactly the same downtime when it closes. It didn't. That means that valve is taking several, I would say currently a couple of hours to close. So it's affecting his sector number 11 and number 12, and then it actually closes there and all the sectors run at the same time. We can see that in here, but also we can see that in the sensors that we have on the ground. And I know it's sensor number 6 because I detected that yesterday. Let me quickly move you to that. Actually, it was already there. And you can see exactly the moisture in the ground that tells me that there is too much moisture in the ground. When there's normal irrigation happening, we have a peak, and then over the day the peak goes down, and there's another peak on the second day. In this day, because of the problem, the moisture was just continuous high, and that was showing me for two values, that one, the pump was still working, second, I could see exactly where was the problem. He went there yesterday, he fixed it, and now things are working fine. Actually, he needs to go there again because valve number 9 has a problem and he needs to replace it. But we can do that remotely and without even noticing what's going on. Last year when we implemented the project, one of the comments that this farmer, which has the 4th grade, told to his brother, which is a farming engineer, was exactly that. Before these guys came in, we didn't have this amount of problems. Yes, they did, and he knows that. They never noticed that they had these problems, and they were losing crops, they were losing plants, because they could not see what was going on underground, not at the top level of the ground. Now, just quickly showing fusion, and that's exactly what we do. This is our application, and we can, on the map, see exactly what's going on. We see each sector, what is the moisture, we see when the valves are activated, or we can even, if it opens, activate valves on demand. And that's done from Resende, 2 hours away from where the farm is. Thank you very much. I'll move for questions, so if anyone wants to talk to me, feel free.
Question, please. Yeah.
You didn't tell us which sensor you are using. You said that it captures a lot of your data.
It's our sensor. We developed it. It's open source, so we got apart from here, apart from there, and we developed the firmware. The radio is an RS-485 from the Dragino. You can get anywhere. A fork. The fork is a 9-in-1 fork, but then we developed actually the firmware to allow us to actually measure those. It's our IP, and we have it available. Dragino has been chasing me already for a year to try to understand what have we done because they don't have it, and we do.
And another question: why don't you also install third sensors on the valves circuits? That way, you really get the notion when they are connected, when they are disconnected, and you can even.
Actually, we do it because there's a main flow meter that allows me to capture that data. So if a valve is open, I see the flow coming from the main flow meter. If my order is to close the valve and I still see flow coming from the flow meter, that means there is a problem, either a leak or a valve that is damaged. Yes, I understand what you're saying. It would be great to have a flow meter on each sector. That becomes already, that crosses the line of what the farmer wants to invest. If we can do it with software, even if it's not actually accurate, but gives us the information that they need.
Great.
I'll talk. So I met this guy. Right, I'm trying to give you a few lessons from my perspective. Now, hands up if you were born between 1970 and 1976. So Malcolm Gladwell, Blink, talks about the year you were born will dictate your success. I was born in 1974, I graduated and went to London in the dot-com boom. I made a lot of money at the time. Down to me, yes, but because of the opportunity this technology transformation created. I was in London, and it was UPC went from one person in mergers and acquisitions to 50 in a year. This dot-com boom is nothing compared to them. We've never had it before. So 3 years ago, 2018, I went to New York for Deloitte. I wasn't working at the time, and it was a Retail Federation conference, and it was Retail AI. Mostly Israel. Some confessed to being ex-Mossad, some didn't, but they all were. And I recognised the signs were there for the dot-com boom. Long story, but I ended up in Havana, 2022. My background is bipolar and business. So I finally got my bipolar under control and I was ready to work, and I met my fiancée, and I said, I'm going to put a team together in Havana. So I found the guy that set up the first taxi firm in Cuba. This guy is I'm the Elon Musk of Britain, he's like the Jeff Bezos of Cuba. This guy is an outlier. He had a big Mercedes, He tried to get me to do an AR app for speed dating. I was like, I like your taxi firm, just stick to that, okay? So I started with 1, and it became 12. So I had a team. First thing, Jim Collins, good to great. First the people, then decide what problem to solve. So I had a team, and I said, do you know what? Elon Musk says brain is the biggest challenge to solve. And I personally, my daughter, have been hugely affected by the lack of objective data from the brain. So I had Giselle, and I gave her an open BCI board. And there's a very famous picture of her. She's a hardware engineer, she's an automatic engineer. She sat with a beer can and an open BCI board at 2 o'clock in the morning. And if I describe the hardware engineer, that's the one. So Giselle, who's now in Florida actually, started and we grew a team. So now we have 4 hardware engineers, 2 on hardware development, 2 on the cloud development. We have 3 data engineers, well, 1 data engineer, 2 computer scientists, but real computer scientists. We have 2 doing 3D design, 1 Unity developer. The reason we have 4 teams, there's a very good podcast called Odd Lots. There's a German doctor that said it's division of mind, not division of labour. So outlying countries with better GDP have a division, multiple minds solving a problem. So to solve the brain problem, we had to have 4 different component parts. So let's fast forward 3 years. We're about to launch our first MVP. I'm skint, I've lost 3 houses, I've lost, not relationships yet, but it's been hard. I flew to Cuba with £5 in the bank and couldn't afford a coffee in the airport. But the pride I have with Jonathan being here with me today, Jonathan was one of the fortunate ones. My job was always to get everybody out of Cuba. Jonathan managed to get a master's in Cantabria, and I'm looking at him to come to UCAD to do a PhD, because I'm trying to persuade him that Portugal, not Spain. So, lesson number 1. I want to try and teach the PhD students. It's about you today. This day is about the PhD students, not about the older people. We're just there to guide you so you can build a legacy for the university. I've got one of the lessons now. Okay, one of the lessons is, it's not the problem you solve in your PhD, it's the lessons you learn solving the problem in your PhD. Do not get too attached to the problem. How that came about with our organisation was, at 2 years, at 2.5 years, we had no progress really, no tangible product, anywhere near that. But we built infrastructure. We built the edge-to-cloud pipelines to allow us to capture data from the sensor and get it to the cloud. My data team produced nothing at 3 years. It was in a repo somewhere. But they learned about time, reference, signal, whatever, machine learning. The lessons they learned with the brain, we had an opportunity I never thought. Opportunity coming from nowhere. I sat on a plane to Cuba. I met a guy next to me. He happens to be an entrepreneur and engineer. He designed and made the most expensive motorbike in the world, the Icon Sheen motorbike. He didn't know Cuba, the credit cards don't work, there's no rental cars, there's nothing. He called me the second day because I gave him a SIM card and said, Ben, I need your help. So he came to Havana, and I said, my 3D team want to model your bike. No commercial benefit, nothing. But my team wanted to do it. It's like, if that's for you, we did it. So this bike was modelled in 200 parts in Blender. No money for it, nothing. But I met this guy after 6 months because he wanted to do brain work. I said, what about the bike? He went, go to the National Motorsports Academy. They have 9 out of 10 Formula 1 teams with students at their academy. Go and just talk to them. So I met Kevin, who runs it. He went, talk to Kieran, Dr. Kieran Reeves. Kieran Reeves did a PhD in optimization of engines through reinforcement learning in 2020. He told me a month ago, he said, Ben, when you walked into my workshop, I remembered my PhD. I had forgotten about it. And I'm now running an academy, looking at academy platforms. I said, well, wake up, because you're now back in your PhD days. He then said to me, separately, if we do what we do, we will disrupt Formula 1. Since then, he has his Formula 1 spies. Then he comes back and saying, they're not doing it. They're not doing digital twins. I've done my research. We don't know yet, because nobody knows. Everybody wants the answer. If you talk to an investor, they want the answer. Well, listen, Einstein said, if I knew what I was looking for, they wouldn't call it research. And I believe that Havana and Utah is the ideal place to do research-based technology. You have to be tranquil. You have to be pragmatic. And you have to enjoy your surroundings. It's vital, because the days are long and it's hard. It's hard. So that's about enough from me, apart from saying it would be wrong of me not to talk about the real people. And that's Jonathan right here. So any non-technical question, I'll do my best. Anything hardware related, it's Jonathan. If I talk about what we do, I'll disqualify most of the room, but I will say, I sent an email, anything you want to share or learn about what we're doing, we're open. I filed 5 patents. Tip number 3. I got quoted £10,000 for a patent application. No, ChatGPT, £60. Go to the UK IPO office, it's £60, you have 1 year to prove it. Go to ChatGPT and say, this is my technology stack, write me a patent. That allows you to talk openly. Yeah? And that is so vital, because then you start thinking about patents, and it comes down to patents. Because when you get to the investors, they'll say, what are your assets? And I say, what are your sales? Well, I've got them. I don't even look at customers. Duolingo founder said, the only thing better than making a lot of money is making no money. Right? My non-exec director is a top guy at Google. I had 3 years in saying $1 billion revenue or 1 billion users. If you can't do that, don't talk to Google. And he installed it in me. Find the market, find the proposition. And those young people who are here now, doing PhDs or whatever, you are the lucky ones. I was born in 1974. I came out of the technology boom. You are sitting here now, and there will be the next breakthroughs in the next 5-10 years. There will be. We didn't have it in 97, that happened in 2004. So these last 4 years is just a training ground. You could be one of them. Josh Wolf, listen to his podcast, and stop doing them now. But he said, with this technology revolution, the last one in 1996 was restricted to London, New York. You had to be in San Francisco. He said, this one, it could be 2 people in Mexico in a bedroom. It could be 2 people in Villarreal. We don't know, because it's completely different, because we have the internet. We have the access to technology, it's cheaper. You'll see on here, we've got a video of an application I did to Infineon. It's on the video, we don't use it. We have a Raspberry Pi and a Halo 8 as an edge processor. I had to do this video for their challenge, which I didn't do. But it's $10, I don't know how good it is. I've got time for my guys to research it. They've got a piece on for $10, and they've got a software called DeepCraft to embed the tiny ML on that. I don't know if it's any good or not, but that could be a way of getting edge AI cheaper, quicker, whatever. And this kind of hardware, software available now, but go deep. Don't go light. You've got to go deep. 10-year time frame. 2035. Oh, that was the lesson. So the reason I'm here is somebody said to me, the UK will never understand your technology. You have to go to 2 places. Horizon Europe or the European Space Agency. Yeah? If you talk in Portugal and nobody understands what you're talking about, talk to Europe. Talk to the European Space Agency. They have something called OSIP. It's an open innovation platform. You can throw an idea and they give you 50 grand. I did it, right? And I got accepted to the experts. Yeah? And I didn't expect it, but once you get in there, but I got tipped off from this from the UK Space Agency, right? This is the key part to it. Bureaucracy in Cuba is complicated, but compared to the European Space Agency, it's simple, right? But as a nation, as a Portuguese nation, you have the right for written feedback on any European Space Agency application, right? So they sat me for 2 months. I got ChatGPT to a legal letter to the European Space Agency saying, by the ECE Charter, can I have feedback on my OSIP? 4 days later, I got a response. So my tip to you is, go to the European Space Agency, navigate their system, register for an OSIP, they've just launched another one. Whatever you're doing, they're doing in space. So I looked at pharmaceutical fermentation or vineyard fermentation. Actually, fermentation in space is a huge thing. So whatever you're doing now, they'll be doing it in space, especially with electrical engineering. So this is a presentation we did for the Infineon Challenge, and the key to it is based on one of my 3D designers of mine, the team's 3D designer Camillo, who did software engineering and 3D design at university, has modelled the car. So when you're looking at the model here, it's completely in Blender. He took 2,000 CAD files and converted it. We're now doing a whole car part by part. For the reason is we're going to be doing reinforcement learning in 3D simulation using Unity. And final point, is our overall goal is looking at, we're doing brain data, car data. So we're interested in the human car behaviour data. How that interacts. Because Kevin, who runs the academy, said, driving a Formula 1 car is like ballroom dancing. So it's the interaction of the human with the car. Yeah? And they only get subjective data. Mechanical engineers is my client. They're only getting subjective data from the driver, how the car is doing. I want to give that mechanical engineer objective data to go back to Lewis Hamilton and say, it's you, not the car. Don't blame the brakes. Yeah? So this is, I'll finish now because I'll just talk forever. This is a video, is it, Sergio?
Next. Yeah, speed that, please. we are on time. So,
Current systems tend to be either too slow or they rely heavily on that cloud infrastructure. And that introduces inaccessible data. In extreme environments, that can be the difference between what's called stress. There are a few key things that we have to say about. First, it's the complete mechanical solution. Second, true edge AI. Third is the immersive XR visualization. And finally, it's already been proven out in the laboratory, which is arguably the most demanding high-stress environment you can find. We're wiring up the systems in our test vehicle, the Module G2, connecting with CAN bus, the IMU, the GNSS, directly ensuring we get robust, clean data capture. That's the foundation. July shifts focus entirely to intensive model training. This is where we use DeepCraft Studio. We're basically teaching the AI to understand and, more importantly, anticipate complex mechanical behaviors. We call it deployment and visualization. We take those trained, high-performance models and deploy them. They start streaming clean JSON data output demo day in Vienna, then at the Infineon Startup Night in Munich, and at the Invest Austria conference back in Vienna, aiming for pretty powerful demonstration to show data-driven simulation using motorsport telemetry. The goal is for people to walk away understanding that this isn't just abstract data analysis, it's a living, dynamic insight into incredibly complex systems. The end game here is a seamless, genuinely plug-and-play embedded AI module. Think of it as a self-contained little box or unit that you can integrate pretty much effortlessly into almost any vehicle platform or even industrial system. This module empowers users with several key things: continuous, proactive system, health monitoring, watching everything all the time, critical, real-time predictive safety alerts, catching problems early, intelligent adaptive performance tuning, potentially adjusting settings on the fly for optimal output, and just overall deep, effortless integration, making it easy to add this smart local intelligence to existing or new platforms. To achieve something like that, you need the right team. And we've assembled an exceptional group. They are fundamentally embedded first people, deep hands-on experience in exactly these kinds of demanding environments. On the hardware and systems side, we've got 4 dedicated engineers. These folks, they live and breathe this stuff. Infineon, PSOC, Modus Toolbox, UART, SPI, CAN, FD. That's their language. They make sure we capture that data reliably, efficiently, right from the physical world. So on the AI front, we have a team of elite DeepCraft experts and specialist time series modelers. Their particular genius is training these highly compact models. Lightning fast, yet incredibly powerful. Purpose-built for the constraints you find on edge devices. It's not big data in the cloud, it's smart data, processed efficiently right where it matters. And then, of course, bringing it all to life, we've got our visionary Unity and visualization crew, 3 exceptional 3D designers. They're the ones masterfully crafting that digital twin experience in immersive XR, making all that complex data intuitive and understandable. Plus, we have our proven test bed and a strategic partnership with the National Motorsport Academy. It matters because fundamentally we believe mechanical intelligence needs to live closer to the metal, closer to the machine itself. Traditional cloud-based telemetry has its place, definitely, for long-term analysis, but for real-time, critical decision-making. It introduces latency, it introduces dependence. That can be unacceptable when seconds or milliseconds count. Our system decisively closes that gap. It offers truly unrivaled edge inference, instantaneous, real-time feedback, and that truly immersive interaction.
Thank you, man. Questions? No questions? No. I really want to know where you have tested it. Only in Cuba?
Test what, sorry?
You've said in the speaker, and even in the movie, talking about the amounts of data, the real data, but
Okay, this was I didn't actually get accepted for this. I got rejected from Infineon, which is fine. I didn't want it. This was just, Anyway, we have a 5-year data deal with the National Motorsport Academy.
okay.
So we have monthly testing at Silverstone. But one thing I've learned about doing deep tech is it takes a long time, and you've got to just leave it with the engineers. So at the moment, this week we have hexadecimal data decoding of the CAN data, which my team identified, and then Kieran said, let me get that to you. So I'm proud that my team identified the problem before the client. So we are this is marketing. My team are not involved with this. This is the bigger picture because they wanted it.
Good afternoon to all. I'm David Macario, the Innovation Manager of EFT Group. First, I would like to thank the opportunity to Professor Salviano, that is not here present today, but I think is listening or remotely connected. Okay, and all the PhD teacher team, okay, for the organization of this event and the opportunity for us to present our company. So, I'm here, I'm David Macario, I'm the Innovation Manager of EFT Group, and I'm here to present, do a very fast presentation about the perspective of innovation in the industrial company, okay? I will start to present the company, the group, our industrial processes, and give you, make a trip by a roadmap of innovation, and at the end show you an example of an innovation project that we are working, okay? And at the end, okay, I'm open for questions. I will try to be as fast as I can after this good lunch and this good view and with this good ambient. So, HERT started in the 90s as a finally based company producing textiles, laminates, technical textiles for footwear, furniture, and so on. So all kind of textiles, all kind of glued, multi-layer textiles you can imagine. We produced it in the 90s for the shoes, for furniture, and so on, for ironing tables, and so on. By the 2000s, we have the opportunity to start manufacturing this kind of materials for the automotive sector. First, doing raw laminates to fluorescein, okay? So we're starting to do laminates of fabrics and foams to make the seats of the cars and some of the upholstery of the interior of the car, okay? This gives us the opportunity to grow very fast and to internationalize the company, and I will explain you this later. But, okay, we maintain until today, and today it represents more or less 9-10% of the incoming of the company, the traditional production lines for footwear, for technical textiles, and we have also an adhesive, a small adhesive company, okay. So, nowadays, our headquarters are in São João da Madeira. Our core business is our components for automotive interiors. So anything you see in the interior of the car, and I will show you some examples later, we can manufacture internally. And this is a resume of our industrial processes. Okay, the lamination, that is gluing together multiple layers of flexible materials, the cutting, the sealing, the covering, and the foam injection process. Okay, we have one R&D center that I manage on our headquarters in Portugal, and we have at now 5 people at full allocated to R&D. Okay. So this is our presence in the world. Okay, our headquarters are in Portugal, but we are present in Romania, Poland, Czech Republic, Morocco, and Mexico. And this is mainly for how I can say, to optimize the logistic chain, okay? Because we produce the parts that will be integrated in the more complex environment in the car. So we need to be near our clients, okay, to produce and provide as fast as I can in a short trip, okay, the components. So is why that we have, and this could sound strange for some people. We have some operations in some of these countries, some projects that that give us a not so good return, but we have these operations to guarantee other operations that give us the higher incomes. Okay? These are some of our clients. Here we are mainly a tier 2 company, so we produce for the companies that deliver the parts to the OEMs, but also we provide some parts directly to the OEMs. For example, we have now starting a big project in Czech Republic for directly for Volvo. Okay, okay. These are some of our partners, and for you to understand the level or what we work, and the company in Portugal that is doing parts for all these European brands. Okay, this is the resume of our industrial processes. I will make a very short turn about that. I think this will be important for you to understand the students and also the teachers, ways to collaborate in the future, ways to think ideas to optimize these processes, and this is why that I'm showing this. So we have different kinds of process of laminating stuff in raw, okay? By flame, by hot melt, by calendar, okay? We use different processes based on the production currency and also in the kind of materials and we are managing. We also have automated cutting technologies for different kinds of materials. We use CNC machines with automatic knives to cut some materials. We have press cutting for the natural leather. We have laser cutting for some materials. So we have also these processes. And from the sewing process, from the manual until the full automatic sewing process with perforation, okay, to create breathability and some effects in the fabrics. So, as you see, as PhD students, there is lots of opportunities to integrate technologies on these materials, okay, in this process, to make the processes more efficient, okay, and also to try to integrate in the sewing process, in the covering process, in the lamination process, try to integrate technology, intelligence in the materials, okay, that can give us, as manufacturer, added value to our product. Okay. This is a line of an automatic line of injection of polyurethane. If you know, in your cars you have some parts, for example, in the armrest, in some parts where you have some soft touch. Sometimes it's from the lamination of the material, but sometimes it's from that property that is, we have a plastic part and we inject directly in the plastic part some foam regions, okay? And this could be interesting because we have all the industrial technology to produce exquisite parts in foam and with different parts and with different types of foam, okay? The big issue here is our production currency, that is thousands and thousands per hour, okay? This is the main, let's say, limitation to do small productions, okay? But we can start testing some smart materials manually, okay, and go ahead. These are examples of parts that we do that are integrated together, okay, in a door panel, a center console, the IP of a currents, and so on. In the field of innovation, I will be very fast. Okay, these are some of our partnerships. We base our innovation process in strong partnerships. Okay, I'm here also hoping to go ahead with the partnership with UTEP. Yes. is that the idea? The idea with Professor Salviano is that, but okay, we started, we based our R&D effort in strong partnerships, first with the innovation clusters, okay, later with the universities and research centers. We have already, and I like to show that, to explain that our innovation process, we have guidelines to do the innovation, because sometimes it's not so normal in the companies, and mainly in Portugal. Okay, we do innovation because I think this is straight ahead, I think this is more efficient, okay, but we have already pillars for the innovation, and we try at least to orientate all the projects with these lines here. This is interesting, okay. This is a short of our roadmap to show you. We have these are examples of projects we are working. We have projects funded directly by the Portuguese funds for the resilience and the recuperation program and other funds. We have also projects directly funded by the European Commission, for example, like TDAL and T-Extended, and I can talk a very little about those projects. TDAL is a big European project to research in big data lakes, okay? In big data lakes. And we enter as an industrial partner to provide our production data, big data sets of production data about let's say commercial area, logistics, production, to a big database. And you asked me, okay, this is more or less normal. Also me, I have done this in the past. Okay, the idea of the European Commission to help to give money to this kind of projects is to test. We are here as a test bed, as an industrial pilot. There are pilots in the bank, in the health, in the agriculture, in public services, and the idea is to test strategies to manage big lakes of data and very different kinds of data, okay? And to understand how we can control the access and how we can extract value from this data, okay? The Extended is also other European funded project where we are working in strategies to recycle our residues, our production residues. At the end, what we want to tell to our clients, we are researching and learning how to transform residues from the car production in other parts for the car. This is already possible today, and the big, okay, but we are doing, let's say, the perfection of these techniques, but the big challenge here is the cost. Normally, recycled parts are a little bit expensive, could be not too much, but at the end our clients want, they tell, okay, I want a very green car, whatever, but at the end the cost is the limitation. They tell us, oh, I can do this anywhere by less 2 or 3 cents, and okay, but we do that because we know that we must be prepared for the future, okay? And we understand that in 100 years, we more or less burned resources that take us millions or billions of years to be created. So we have to do everything different, and we have to be ready to do that. Another note about sustainability. I know that this PhD is more in the field of the electronics engineering, but nowadays people tell us, oh no, sustainability is more or less a kind of conversation, this don't have practical utilization, European Commission is investing too much money in sustainability. Okay, this is true. I give you one reason, the lack of resources. But other thing, and I will show you a product later. Think, for example, that with this kind the geopolitics, we have a crisis, and we don't have access to the petroleum or some raw materials. Sustainability and the project in the field of the sustainability could give us the answers for that needs, because we are doing developing chemicals that can substitute the chemicals from the petroleum. Okay, they could be a little bit more expensive, but we have solutions. Okay, we can make composites, we can make textiles and other materials, so we can continue to be independent. Okay, and at the end, strategically, this could be very important. I will show you about that. One idea that we translated for one project that we are doing now is the BIT project. Is a project managed by CITER. CITER is a big research center based in Famalicão. I don't know if all you know, and is a big research center focused in the textile industry. Okay, so our idea was based on using the industrial process that we have at EFT, acquire know-how to develop biocomposites, so materials that can substitute the plastics in the car. Okay, and we started developing, and we developed biocomposites based. We tested. I will don't enter in the detail, but at the end we get biocomposites made from hemp with biopolyamide. From then we can make parts that can substitute the plastic and also can substitute some semi-structural parts in the car. Okay? These are examples of the process we have. We have a first process of impregnation of the material with the biopolymer, the textile with the biopolymer. And our lamination company has machines to do the impregnation. Yes, we have hot melt machines. So we can melt the polymer, and using some kind of coating, we can do the impregnation. We have cold and hot pressing machines to do some thermoconformated textile parts. So, without knowing, we are most near to produce this kind of materials that we all think that we are. And working on this kind of projects can give us the path to be competitive in the future. Okay, this is the example of the development. I use this presentation also to do these other things. So I have here, okay, what we do, the challenges we have to reach with the biocomposite, the characteristics of the plastic for a semi-structural part in the car, and we are very, very near, okay? And to show you one thing, these are some pictures of one intermediate prototype where think that EFT is a company that takes a project from a client and does the industrialization, don't have any kind of design and creativity in the process. The only creativity we have is optimizing the industrial process, and we started doing the design of a part of a car, using concepts from biomimetics and others. Okay, we start internally, and with the help of the researchers, doing the design of the part. Later, we join with other company also in the project to make this green part here, this coating here, and we ended with a medallion with the armrest for a door of a car that we can present to our customers. Okay, so we can position. We start positioning now as a simple manufacturer, but a company that can work with the design, okay, optimize, be sustainable, okay, and deliver a final solution. The consortium is here, okay. And other interesting thing, that I will show you. This is a comparison between the flexible materials. Is that okay? This is a photo of an intermediate prototype that we presented in an international fair of composites, the Jack Composites 25 in Paris. And look that the final prototype we use, like you do in carbon fiber, we use the composite made from the textile, and we use the appeal of the composite as a static form. Okay, and this led us to, or make us to have more effort developing the chemistry of the polymers to make this composite resistant to the UV light and to the abrasion of the day-to-day use. We are also working in the final life cycle of the product, okay, testing different kinds of techniques to do the recycling of this kind of composites. To finish, I let you with some ideas or some research lines for ideas for you professors, students. I point to the end for the digitalization and comfort. Okay, some ideas for future collaboration or to apply technologies that you are already working. Okay, in our group. Okay. Think that all the stuff we can introduce in flexible materials, for example, whatever, functionalize a laminate to give characteristics, to have some behavior with electromagnetic fields or whatever. Okay, we are also starting working this in the safety and defense sectors. Okay, we are open to work. We are open to work in projects, to participate in projects, but also open to discriminalized or industrial process to make some initial raw tests, okay, to make if something is feasible. I will go back. Only one thing that I forget to tell you. You see this small project here, interior smart lighting. This project was a project between ERT and CMOLDS and was entirely funded by the companies. We have no public fund. And the project started with the idea of test different kinds of lighting process or backlighting indoors in cars. We start testing materials, technologies, and also inside our companies, everybody tells us, okay, do that, but we don't do anything at the end. We don't have the capability to do that. This will not work. Blah, 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 blah. This project started when I entered in the company, was one of the first tasks they give it to me. Okay, let's say, comes this new guy, okay, let's take something that is in the stop it, and let's see what the guy do. I start talking with the guys from CMOL. We start doing some tests at our free times, and today this is in production. We presented this to VW Group. Okay, it is entered in production. I remember when my colleagues from CMOLs that take the news first, because they make the first contact, they have the news, they tell me, they contact our commercial department, they don't give importance, they call to me, please call to the commercial because we have as fast as we can to give the quotations to start the trials and go to productions in 6 months. So, to tell you that not all the times innovation is not to have a product. It's sometimes people try to think, okay, innovation don't have application, immediate application, but cannot create business. No, this is not true. It's a matter of trial, persistency, and strategy. So thank you very much, and sorry if I've been a little bit
Yeah, I have a question that is for
Yeah.
the presentation, very interesting. In your material, do you perform a life cycle assessment of all the parts you do?
we are start working on that. This is not my specialty, but I have two research projects. This research project of the biocomposites as a part of studying the life cycle of the product. So to tell you, we are now learning how to do that. And in the field of this project, they are creating automatic platforms to help the companies to do this assessment, let's say.
Yeah, now it's a very important indicator.
Yeah.
And I am taking my PhD in electrical and computer engineering with the proposed title for my thesis, AI-powered multi-product disassembly, robotic self-production manufacturing using learning from demonstration. For the development of this thesis, I count on the support of my supervisors, Dr. Peter Fleet, Dr. Miguel Silva, Dr. João Souza, and with the collaboration with Dr. Luís Rocha. Jumping to the motivation slide, it is necessary to ask why to use robots. A report from Cisco stated that the average time for a human to change from smartphone is roughly 4 years, while on laptops is around 3 years. This means that multiplying these years by millions of us in the whole world, it is pretty easy to stack lots of unused materials on waste streams. Nowadays, all of these assemblies performed by humans, which can be dangerous since most of these electronics have hazardous materials inside them. It is in here that robots can make a difference, by replacing the humans in the most complex tasks and automating the disassembly. Based on this motivation, the main objectives of this PhD are to develop a robotic self-data collection, which will comprise motion capture systems like a flip chart, RGB cameras, a robotic manipulator, and several actuators. The main purpose here is to collect all the data possible during a disassembly demonstration, like videos of the human operator performing it, the position of the tool, force sensors, etc. Next, after the data extraction, we can proceed to the training phase, where one of the several behavioral cloning algorithms is chosen and trained with the developed dataset. Third but not least, most of the tests that can be performed by robots are the unscreening tests. And for that, for the system to be capable of understanding and detecting the screws, a whole algorithm will be developed in order to detect, categorize, and remove the screws. A secondary objective will also be developed, not compromising the other ones, where the purpose is to allow the user to send voice comments to an LLM or a VLM that will analyze and suggest the best action for the robot to take. We'll also include voice-activated comments and active listening. Based on these objectives, I'll try to answer to the following research questions. The first one, what are the most effective machine learning techniques for training learn-from demonstration models? The second one, to what extent can learn-from demonstration models generalize across different operators and object instance in disassembly tests? And the third and final one, how effective are neural networks models for detecting and segmenting small technical components like screws in complex scenes? For the current developments, I have a cell on the left with all the sensors that will be used to perform data collection. As can be seen in the image, there are already installed motion tracking cameras, a 2D camera, and a robotic manipulator. I am currently working on this cell, making tests with several other sensors to get the best combination. On the right, we have a system that will be used to detect, classify, and suggest the tool for the screw. It first starts by detecting the screw using a YOLO V11 model, and then proceeds to classify it using counter-matching or classification models. Then, the size of the screw is calculated using segment and particle data. After all this, the tool is suggested based on several user information available. The schedule that I have designed for this PhD can be seen here, and it is divided into following tasks. Task 1, thesis management. Task 2, literature review. For a systematic literature review will be published on the topic of robotic disassembly. Task 3, robotic disassembly cell, where all the previous objectives are listed and will be developed. Task 4, system evaluation by real tests and simulation. This work is executed in collaboration with the Center for Robotics in Industry and Intelligent Systems from INESTEC, especially in the Industry and Innovation Lab. For the PhD program, I chose the curricular unit Image Processing and Computer Vision, lectured by Professor Peter Flip, which I will conclude after the submission and acceptance of my article Automated Skill Detection and Classification using LOV11 and OpenCV for Precision Tool Recommendation and Localization. My second optional curricular unit is Biological and Natural Inspired Algorithms and Systems, lectured by Professor Ivarkovich. And to complete the unit, I am currently waiting on the review results from the paper Robot Explaining from Analytical to Computer Intelligence Approaches, which is currently submitted into the Journal of Intelligent and Robotic Systems. The Unity Research Theory and Methodology is also concluded, and the seminar is in progress. In here, there are two graphical abstracts that describe the objectives of this PhD thesis. The first one, or the main one, illustrates the collection of the disassembly process by the human, the training of a behavioral cloning model based on the dataset collected, and the posterior execution of the same movements by the robotic manipulator. The second one illustrates a natural language interaction between the human operator and the robotic cell, illustrating the operator normally talking, the conversion of its speech to text, then prompting it into the LLM or the VLM, and then receiving a response and sending it to the robot to be executed. In this slide, there are the references that support all the information presented in this presentation. And with this, I can conclude my presentation. I would like to thank you all for your attention, and we can proceed now to the questions phase.
Thank you, Pierre. Questions for you. The first one is, I want to know if you have some kind of scholarship for doing this PhD.
Yeah.
You have a scholarship at UNESCO?
Yeah, so this project is being developed under the objectives of the European project, namely IBOT for CRMs. So, yeah.
You are researching in this project?
Yeah.
Okay. Without any scholarship from the FCT?
No, not yet. I have applied for a scholarship in FCT.
You are
but
waiting?
yeah, I'm waiting for the results. I think they will come out in the beginning of August.
September. Another question is about your data set of images.
Yeah.
The data set of images, do you already have it, or you have to collect it?
I think that's one of the things that make this PhD something that can be unique, because there's a really small amount of disassembly data sets. So it will be a hard test, not for now, but for like in 2 months from now, when we have all the sensors that we can use to collect the data, and only then we can collect the data. So for now, we don't have it. We only have the robot trajectories that we can manually or by simulation get, but not the rest, like the human moving the tool, the movement of the arms of the operator. We can take that. So only from 2 months from now, that's what I'm counting on. So.
My name is Inês, and today I'm going to present my PhD project entitled Intelligent Management of Energy Storage Systems, Optimization of Self-Consumption and Provision of System Service. My supervisors are Professor João Batista and Professor Tiago Pinto. The energy transition is establishing a new paradigm in the energy mix and the energy market, requiring greater system flexibility. As a result of renewable integration, energy prices in spot markets have been going down. Activating reserve markets is key to ensuring that the systems continue to operate under critical conditions. By providing system service, producers can earn more than in a spot market. This means that when day-ahead prices are low, the profitability of system service tends to be higher. During periods of excess energy generation, producers submit offers to system service markets, and if that's not enough, the TSO directly curtails power plants as a last resort. As you can see in the figure 1, this has led to curtailment in the solar power plants. Figure 2 shows that numbers of curtailments have been increasing since 2024. As a result, increase in curtailments extend the payback period of assets, pushing producers to participate in system service markets. In this presentation, we will focus on secondary market as it offers higher liquidity. In secondary regulation markets, compensation is provided in two ways. First, for keeping the asset available, and second, for actual activation in real time. This means that producers can pay just for being available to increase or decrease their power output, even if their service isn't activated. These slides present a case study, as shown in figure 3, between 8 a.m. and 6 p.m., energy production exceeded consumption, leading to a drop in spot market prices, as illustrated in the figure 4. At the same time, secondary market prices were higher. In such situations, when bank prices are above market prices, producers can maximize their return by submitting offers to secondary markets. This example shows that when spot price drops to zero, revenue is also zero. However, by submitting bank offers and having part of them activated, producers can earn over 4,000 euros in just 1 hour. To do this, system operating points must be adjusted. The goal is to develop an optimization algorithm that decides which offers to submit in each market to maximize returns. By strategically submitting personal load offers in the day-ahead market, we can receive capacity to provide both upward and downward regulation service. If the TSO activates this service, the energy is compensated to a higher rate than in the spot market. In terms of curricular planning, some courses have already been completed. Additionally, an article entitled Application of Time Series Clustering for Improving Forecasting Energy Market was published under Option 1 and presented at the International Conference in European Energy Market in Lisbon. Regarding my timeline, it's divided into 8 tasks, and I'm currently working on task 1 and 2 in parallel. To conclude, I'd like to present my graphical abstract, which provides an overview of the entire project. The main goal is to develop an optimization model capable of determining the appropriate bids in each market based on respective remuneration. The underlying idea is that by participating in multiple markets in parallel, producers can enhance asset profitability. This is my reference, and thank you so much.
Well, yes, I have a small question about your topic. Well, this topic arises to a need you identify in your professionality. You work in a company, in dealing with the markets.
Yes. Now with the day-ahead market.
Day-ahead markets, yes,
Yes.
in the microphone.
Yes, but in the future we will work with the market systems, okay? And we have to know the bids and what markets we will need to work in determined hours. So the main goal is define the bids for the markets and what markets that we will need to work.
To maximize the revenue.
Yes, yes.
It's an interesting topic.
Just because you are the supervisor, I will ask her a question, if you don't mind. Inês, have you ever thinking, the consumption of energy is directly depending on the kind of charge that you are demanding?
Yeah.
Imagine an enterprise that chargers, the electric chargers,
Yes.
they collect charge from one other place to the other place. And you ever think of have this kind of input to your system, to your decision system, that is, historically, where you have a greater consumption.
Yes.
The times of the day where you have that. But if you move that kind of need during the daytime
Hours.
to other hours where the energy is low, the cost of energy is lower, then you can lower the prices without doing anything, without getting anything extra from the grid.
Yes, but in this work is more or less the same thing, because the plants don't need to activate the power, be it for up or down the power of the plants, and they will be paid for that. So one part of the secondary ban is that the producer don't need to do anything, only put a bid in the market, and if they need that capacity in that hour, they will be paid for have the capacity to up and down the power. So if not related with the load or charge, determined charge, but the market will do some.
To adjust to the market.
Yes.
Yeah, thank you.
Good morning, everyone. My name is Noor Hussein from Jordan, a PhD student on Electrical and Computer Engineering Department at UTAB. I will introduce my thesis proposal, which is titled by Exploring Deep Learning-Based Watermarking Techniques for Image Forensic Systems, under the supervision of Professor Silviano Soares, Professor Congalo Carnas, and Professor Joa Carvajal. Let's begin with the context. Digital images become an important carrier for people to access information in this big data era. They are becoming increasingly important in various fields. Here, our interest is in the field of image forensics. There are many forensic infrastructure, such as investigation laboratories, that need to exchange data and cannot work separately without sharing information. At this point, image forensic techniques is a vital need in the multimedia information security, provided that no modifications are allowed to the information during the transfer process over networks. These images may contain private and sensitive information, so digital image security is critical for this reason. And the performance achieved by using deep learning has significantly exceeded the conventional forensic algorithms. Where image watermarking hides copyright marks inside cover image has an important role too. As large language models are increasingly capable of producing realistic text, watermarking techniques are being adapted to not only protect visual media but also to verify and trace the origin of AI-generated text. For motivation, we can compare between classical watermarking techniques that have been developed to protect images and AI-based watermarking, which made a significant contribution to image content security. For three criteria: Imperceptibility is achieved in both schemes, but visual quality and robustness are achieved in our scheme. The motivation is to have the complete information security system and even maintaining the ability to improve future generative AI models. Here we can see the general architecture of watermarking. In the embedding process, the secret watermark, cover media, and secret key are given as an input to the embedding algorithm. Encryption, encoding, and hashing can also be used to improve the security, and the extraction process is the inverse of the embedding process. Here is an illustration designed to understand the fundamental differences between artificial intelligence, machine learning, and deep learning, where AI is the bigger domain with innovations and new sectors. Machine learning is a subset of artificial intelligence, and deep learning is in turn a subset of machine learning. Okay, here we can see the major difference between them is the way the data is represented to the machine. Machine learning algorithm usually requires structured data, whereas the deep learning networks work on multiple layers of artificial neural networks. As we can see in the figure of a neural network, it looks like the input layer accepts inputs from the data, the hidden layer is used to find any hidden features from the data, and the output layer then provides the expected output. Okay, to compare between them, deep learning models are best used on large volumes of data, while machine learning are generally used for smaller data sets. Also, in the machine learning pipeline, feature engineering comes right after data cleaning and visualizing, where the expertise of data scientists is required. Alternatively, there is no need for explicit feature engineering in deep learning. Deep learning is higher accuracy than machine learning, so the probability of high error is less. Okay, the major issues with deep learning-based watermarking are as follows. There is always a need to maintain a trade-off between the three requirements that remains challenging for most watermarking schemes. As we can see, as the LLM become capable of generating high quality and human-like content, this motivates the need for advanced deep learning-based watermarking techniques, not only for images but also for LLM-generated text as seen in the figure. Okay, the main objective here is the main objective of the embedding stage is to ensure watermarking imperceptibility while also taking into account the other requirements. For this, many neural network-based approach has been designed to enhance the watermark embedding system. So, the primary goal in safeguarding the information ecosystem will involve understanding malicious intents behind AI generations. The methodology, here we can see the data flow diagram, starting with data collection, data pre-processing, construction of a predictive model, dataset training, dataset testing, and comparison of algorithms. The proposed type of deep learning will be CNN due to its ability to learn the underlying patterns and features of the images without any prior domain knowledge. Okay, and here is the flow chart of LLM-based watermark. Start with gathering the training data, convert text into token sequences, modify token probabilities, generate output from LLM, AI-generated text containing the invisible watermark, uses statistical methods to detect it and confirm the authorship or traceability of the content. About the methodology, achieve a hybrid technique that provides satisfactory performance like peak signal-to-noise ratio, the entropies, time needed for encoding and decoding, and the size of the encoded image relative to the original one, that maintain the trade-off between robustness and image quality. We can use in the simulation Python or other technologies, and various kinds of images and watermarks act as an input. Here is the schedule, Gantt control by the end of the second year, curricular plan for the courses that is done and which is in progress, and finally the graphical abstract. Okay, we can see the watermark trade-off triangle. The capacity requirement is required in the host mark. This is contrary to the other two requirements. Okay, and here we can see the basic framework of neural network watermarking. In the embedding process, watermark information is embedded into a network through a watermark embedding algorithm. After that, a watermark extraction algorithm is used to extract the watermark information from the model. This diagram of the learning framework in the image watermarking process. The network was trained either to insert the watermark orange line or to detect the watermark sky blue line. The scenario in which both embedding and detection are performed by a trained network is represented by the dark blue line, while input processing and the output processing using learning networks are shown by the red line and the green line respectively. We can notice the reference at the last slide. Thank you for your attention. Good luck for all.
I have several questions. I have one question. Your framework based in AI is to apply
Forensic systems.
science.
Yeah.
Specifically in what?
Forensic image specifically analyzes the image, makes a modification and updating to the image that is used at crime laboratories, investigation labs, and maybe teachers, professors at university could analyze the image. When they use the models generated text, they can tracing the origin of the text, if it is humanized or it is from the AI. When the students give the homework, for example.
Do you have several images to the data set? You already have the data set? Training your model?
The origin of the project started from my master thesis. I work just on watermarking and encryption. At PhD, we modify as a second stage, to add AI-based watermarking. In the past, I worked on a medical image, like X-ray, scan, ray. Now, I will update it to work on a data set like SA1P data sets or any other data sets. It's by experiment will be used.
What you do in your professional activity?
I just do many experiments for a paper which is used the same idea to find the limitations and update it. I start working on models like TB-Llama or T5, which is models of deep learning, and make many experiments to embed, then extract the watermark, and find that if the watermark is fragile or it's weak watermark that is not be detectable, or when I make a paraphrasing for the text, for example, if the watermark will be not detectable. And I made some experiments on something called watermark anything, that I will embed a message localized at any corner of the image, not in a specific location. I have some results to be updated.
Sorry?
Yeah.
In which stage is actually your work today? Because you said that CNNs,
Yeah.
if I remember,
Yeah.
CNNs are, I don't know, the most
Convolutional neural network, yeah.
They are the most recommendable ones.
Yes. CNN is the network that is...
Yeah, I know what is a CNN. But why?
Because it's the neural network that deals with the image perfectly.
For my test, CNN is perfect for deep learning, perfect for the image and experiments I do. But I consider the technology, I make some notice, I make...
But have you done some other tests with the other kind of networks?
Really, no.
So how can you tell that they are the perfect ones for this kind?
Because I make a research and find many papers that have limitations with other neural networks, and they use CNN. I made a difference between them, a table of difference, and find CNN is suitable for my case.
But please have in mind this kind of recommendation.
Yeah.
This is just a recommendation,
Yeah.
because when you state that this is the best one,
Yeah.
you need to
I must-
prove that
yes.
this is the best one. In
Yes,
fact.
I must prove that.
So you must, if you are based on others' work,
Yeah.
that's stating that they have tried
Yeah.
different ones in different contexts. Okay.
I concentrate to find the difference between machine learning and deep learning, if you can see. Then I will go deeply and make a difference between CNN and other neural networks.
Okay.
Hello, my name is Philip Thompson, and welcome to my presentation about my PhD thesis called Multi-Criteria Decision-Making Framework for Sustainable Sizing Strategies of Multi-Energy Systems. My co-supervisors are Professor José Batista and Thiago Pinto. What is the background and motivation of my thesis? Of course, climate change requires the accelerated expansion of renewable energy systems, and therefore also multi-criteria and system design automation is necessary, because energy systems are increasingly becoming more complex, and usually often mostly only cost and CO2 emissions are considered in most optimization models. And an ecological assessment that covers also diverse impact categories are usually mostly disregarded, and CO2 is taken as a sole indicator of sustainability assessment. However, a more holistic approach requires accounting for multiple conflicting objectives of environmental impacts on a broad scale. Costs and most systems are the key. So there are many trade-offs that need to be taken into account. Moreover, the energy system is becoming more complex. On the right-hand side, you can see a multi-energy system due to the electrification of the transport and heating sectors. So optimization models are required that can operate across these sectors, accounting for many conflicting objectives, emissions, costs, and the security of supply, and at different scales. So because the energy system and the modeling is becoming more complex, this leads to non-linearities and also uncertainties that increase the computational effort, and therefore more efficient algorithms are needed to solve the Pareto front in complex and non-linear decision-making spaces. So my objectives are the development of a decision-making framework for the sizing and analysis of multi-energy systems. So I will develop a multi-objective optimization model. My aim is to account for these conflicting trade-offs, also including the so-called product environmental footprint that covers a diverse range of ecological impacts, not only CO2 emissions, costs, and self-sufficiency. So the optimal solution are then obtained from the Pareto front through multi-attribute decision-making methods that cover diverse ranges of sustainability indicators. So eventually the aim is to obtain an optimal sizing strategy that covers diverse sustainable indicators and technologies in multi-energy systems. So my thesis contributes basically to SDG 7, 11, and 13, affordable and clean energy, sustainable cities and communities, and climate action. So the basic novelty of this research is the consideration of comprehensive environmental life cycle indicators into energy system optimization models. So this will capture all the most relevant ecological impacts also on ecosystems and on human health, for example. Moreover, a novelty is the combination of multi-objective optimization and multi-attribute decision-making methods for eventually the multi-criteria optimization models in the multi-energy system. And also the parallel consideration of techno-economic and comprehensive ecological goals across different spatial scales. So what is the schedule of my thesis? I already conducted some literature research and gathered some relevant data, especially weather and technology, specific technical and economic data. Currently, I'm gathering some LCA data. LCA stands for Life Cycle Assessment, to develop the product environmental footprint that was actually developed by the European Union that needs to be now filled and integrated into the optimization model. So I already did some development of the model in Python. So I developed already a single optimization model of a higher energy system covering PV battery, and currently I enlarging the model to also account for heat pump, electric vehicles, and in the future I will develop the model further to also integrate several other storage and generation technologies, also in the heating and transport sector, and also to account for more objectives, not only cost, but also the environmental footprint as soon as I have all the data ready, and also self-sufficiency, also integrated technologies, for example, power to gas, hydrogen, and so on, and heating and cooling. And I will test the model on specific use cases, a house, an energy community, and eventually a district, so a broader scales. So what I have done so far, I have the Clarivate certificate, I have the EPO course, the training from the European Patent Academy and the Web of Science Academy, and I already wrote 2 papers, one review paper about multi-attribute decision-making methods, and one conference paper about the optimization model of the PV and the battery storage system. Currently, I'm working on a model for a journal, and well, this is my graphical abstract. As you can see here, this is the Pareto font that I was talking about before, with in orange the non-dominated solutions that are also that are all of them optimal, and well, I divide the graphical abstracts into motivation, aims, and methods and expected results. Well, and now I'm already finished with my presentation. These are my references, and thank you for the attention, and see you soon.
Thank you, Philip. Well, I have one question. Well, you talked about the multi-criteria objective function algorithm. How the life cycle assessment of the multi-energy system can impact the result of the multi-criteria framework?
Well, as I said before, most of the optimization models consider usually only cost. And if you integrate what I have done so far, I tried it to integrate the life cycle data into the model, and I can see that it's a trade-off between, for example, if you feed in PV electricity to the grid, and if you, in times of low PV production, so buy electricity from the grid. So if you integrate the life cycle analysis data, the optimization model says basically that you should enlarge the PV production, for example. So you should actually buy, although it's a little bit more expensive, you should buy a bigger PV capacities, for example. But if you also integrate the battery, for example, So the battery has a slightly higher product environmental footprint compared to the grid that you buy from the grid, so the electricity that you buy from the grid. Here is a trade-off also that you cannot, so if you want to maximize the self-consumption of PV electricity, you need a bigger battery, for example, but the battery again is slightly worse than the grid electricity, so also here's a bit of a trade-off. So in general, I would say that, as far as I can tell from my knowledge so far, that if you integrate the LCA data into the objective function, into the objective function, well, the PV capacity gets a little bit more, and the battery capacity gets a little bit lower, which is different if you just make a cost optimization, because so because if you
what kind of algorithm you are thinking to use for this kind of multi-criteria framework?
Well, good question. Well, in the future, if I integrate also other generation storage technologies, it will make the model much more complex. And if I add if I add two objectives to the function, which are optimized simultaneously, it will increase the complexity of the optimization model a lot, and therefore I need a much more efficient algorithm, because now the model takes already several hours to resolve, and I don't know if the optimization results are really good in that sense, because it takes already quite a lot of time to resolve. So I think, as far as I have seen in the literature, especially genetic algorithms are used very often. I think they are probably the method of choice. Yes. So the genetic algorithm, for example, or some other forms of machine learning algorithms. So I did.
You mentioned quite a few different areas. Do you think you'll have to specialise in one domain?
Well, the actual objective of this thesis is to build the whole model, like the whole multi-energy system, like consisting of all the relevant generation storage technologies, and integrating the heating and transport sector as well, and so make the system as a whole, which will likely to be in the future, because in the future we will have more distributed energy resources available that are self-sufficient in the end. So the aim is to integrate all these technologies into the model, and then solve the model, integrating several objectives into the model. So that's actually the aim. So I don't want to focus on specific technologies in that sense. I want to see the bigger picture.
Thank you very much. Do you have experience with including detailed regulations?
Legal regulations so far not. But what is interesting is that, especially in Austria, we have now, like only a week ago, a new legislation in energy markets that also account for the varying grid tariffs, not only the varying energy prices on the spot market, also the grid tariffs. This would be maybe an idea to also include into the model. But yes, maybe another opportunity to include some legal restrictions about, for example, giving excess PV electricity into the grid, because I think in the future it will come that we'll only have about 60% of the PV capacity available to be fed into the grid. So not the maximum, especially in summer when there's a lot of PV electricity available. People will not be able to feed all the electricity into the grid. So this would be maybe an idea to also include into the model to restrict the capacity of the PV feeding. Yes. But it's always a step by step.
Yeah.
And I always.
You have artwork.
Yeah.
Hello everyone, my name is Kiko Teixeira and I'm here today to present my pitch for the Physics Planning and Scheduling 2 entitled Enhancing Peer-to-Peer Energy Trading in Rural Renewable Energy Communities. The work is supervised by Professor José Batista and Professor Tiago Pinto from Otago and Engineer Pedro Rodrigues from Indie Energy. As part of my doctoral program, I applied for the FCT 2025 research grant in a non-academic environment, and I am now awaiting decision. What motivates this work is the fact that in most countries, including Portugal, the large majority of the geographical coverage consists on rural areas with poor network installation. In fact, rural grid infrastructure tends to be outdated and weak, affecting the access to reliable, safe, and affordable electricity. Therefore, this work intends to develop innovative solutions to overcome this limitation, enhancing the potential of rural networks, considering renewable energy communities. Renewable energy communities allow decentralized and local energy production and consumption, enhancing energy autonomy, resilience, and distribution, particularly in remote populations. These models enable members to engage peer-to-peer trading, allowing them to actively participate in the electricity market and contributing to grid stability and efficient energy distribution. To improve the operational efficiency of renewable energy communities, energy markets and demand response programs will be integrated to optimize energy costs and revenues while balancing consumption and production. Finally, data integrity is essential for effective energy system management. However, missing or low quality data compromises decision making because it can lead to inaccurate forecasting and inefficient optimization. In this way, synthetic data generation models will be developed to create realistic data sets capable of replicating observed data characteristics, and transfer learning models will be used to learn information from pre-trained models from similar locations and tasks, improving learning efficiency and performance. In this way, the main aim proposed for this work is to develop a multidisciplinary framework based on flexible energy market tariffs and energy trading, optimizing decision-making in rural communities. To do so, the main objectives proposed are the state-of-art review, considering energy trading models, different renewable energy community topologies, different energy trading models, technical and socioeconomic impacts, and electricity markets. The next objective is to understand demand response programs in renewable energy communities, promoting efficiency and engagement, and the analysis of market structures that are applicable to renewable energy communities, active and passive demand response programs, the operational and economic benefits of demand response and load balancing. The third objective is to evaluate smart grid technologies and how they can make rural renewable energy communities more resilient. The next one is to identify approaches that are capable of improving the robustness of decision-making systems, considering the main impacts of ongoing missing or low-quality data in energy systems management, and also analyze and compare the different data-driven models, such as, for example, statistics or machine learning models. Finally, is the design and development and implementation of a framework to optimize the participation of renewable energy communities in energy markets. Here it is presented the timeline of my 3 years PhD program, where I'm currently developing the curricular units. My curricular plan consists of 7 units, where research theory and methodology is already completed. 5 curricular units are still ongoing, including option 1, biological and natural inspired algorithms and systems, and option 2, electrical and energy systems management. The thesis development will be carried out during the 2nd and 3rd year of the program. This graphical abstract intends to, in a simple way, explain the purpose of the work. So, based on the problem that rural areas have weak grids and limited data access, the proposed solution intends to validate advanced peer-to-peer energy trading models, considering renewable energy communities models, and optimization and transfer learning methods to ensure energy flexibility. In a simple way, the methodology consists of collecting real and synthetic data from consumers, producers, or energy tariffs, for example, to develop transfer learning forecasting models. After, advanced optimization and decision-making strategies will be developed to support energy trading within renewable energy communities. Then it will be developed a modular framework that integrates the forecasting models with the optimization and energy trading models. This framework will also integrate adaptive mechanisms, enabling continuous model refinement and real-time updates. In this phase, transfer learning will also be used to share knowledge between different communities, enhancing cross-community trading. Finally, the performance of the frameworks will be evaluated under realistic conditions with different scenarios, considering different renewable energy communities, market structures, and demand response programs. Based on this graphical abstract in this slide, I present my thesis chronogram with 8 main tasks that will be developed during the course of the program, as well as the milestones that the work intends to obtain. To improve the quality of the work, it will also be developed alongside UNESTEC and Polytechnic de Turin. I hope you like this presentation, and I am available to answer any questions now. Thank you.
Thank you, Ida. Congratulations for your presentation. I have one question. You talked about transfer learning forecasting methods, using this kind of methodologies to helping to bring some knowledge to the rural grids to implement the PFP trading and the renewable energy communities. In which way, in your opinion, this kind of models, transfer learning forecasting models, can help to make the energy flexibility in the rural networks more efficient?
So the main idea to use transfer learning is... Okay. So the main idea to use transfer learning models in this case is to communicate between the rural areas that normally don't have a lot of data to analyze and create the energy systems, and connect it to local and near villages or cities that have a longer and wide data sets of energy, of consumers, productions, to create. So transfer learning will be our main bridge to create real data sets that are capable to be applied in rural areas, to have more data from
producers, consumers, to create more realistic data sets. That's the main purpose of using transfer learning.
My name is Shadley Mahmoudi. I'm currently pursuing my PhD in electrical and computer engineering at the Goethe University in collaborate with IBIS Lab at Polytechnic Institute of Vienna de Castella IPVC. My research focuses on distributed HLI image-based localization for indoor industrial environments. And this work is under supervision of Professor Flaviano Solares and Professor Sergio Ivan Lopez. In fact, this research is conducted under the TextPact, which is Innovation Pact for the digitalization of the textile and clothing sector, and it is a national initiative aimed at accelerating the industry's digital transformation. This research directly supports the digital transformation goals of the TextPact by introducing Edge AI solution for image-based localization in industrial environment. Our approach enables real-time monitoring and smarter decision-making on site without relying on cloud infrastructure. To address current challenges in workers and asset tracking, the project contributes to building a smarter, safer, and more efficient factories aligned with the goals of Industry 5. In modern industrial facilities, we deal with dynamic environment filled with various moving entities such as mobile machine, robots, humans. The challenge here is not just detecting them, but also identifying and tracking them as they move through different rooms and workflows. This becomes even more complex when multiple cameras are involved and entities frequently change locations. Our motivation is to design a smart Edge AI system that can localize and monitor these diverse entities in real time and ensure safety, coordination, and efficiency in industrial settings. In continue, this diagram shows the layered architecture of our Edge AI system, which is designed for real-time monitoring and intelligent decision-making in industrial environments. The base and first layer is physical layer, which is represents the real-world industrial environment where people, robots, and assets operate. And cameras also installed in different rooms to capture visual data. On top of that, there is an inference Edge AI layer, which performs image processing on edge device to detect and recognize identity in real time. Then, in communication layer, sends the perceived data from edge device to higher layer, secure and fast. The next layer is data aggregation layer. In this layer, information from multiple edge devices collected and fused, and allowing the system to follow entities across rooms by matching their identity and analyzing their movement. The top and the last layer is the application layer. Here, combine data to make a smart decision, such as sending alarms or controlling machines. The current localization system in industrial environment faces several limitations, and mostly they rely on multimodal infrastructure-based technology, resulting in costly and complex deployment. And mobile node localization is hardware dependent, and only possible if tags or nodes are attached. And mostly they are cloud-centric, which causes latency and privacy risks. And in complex dynamic industrial settings, they have limited stability. To overcome all of these challenges, we propose Edge AI distributed image-based federated learning, which enable local training for global inference for faster, privacy-aware, and scalable localization. The objective of this research is structured in 4 main phases. Third, perform a literature review on Edge AI federated learning approach for image-based localization and tracking in industrial settings. Second, propose a conceptual Edge AI federated learning solution for image-based localization and tracking in industrial settings. And third, develop prototype the proposed solution. And the last one is deploy and validate the proposed solution in industrial settings. Methodology is divided in 5 key phases. First, literature review and problem analysis. Second, data collection and environment setup. Third, Edge AI model design and optimization. Fourth, distributed system architecture and deployment. Fifth, evaluation and comparison. The schedule of my PhD work plan is structured into the 5 major tasks. The roadmap above clearly shows the deliverables and milestones for each task, and timeline below presents the duration of each one for 4 years. Also, I have provided in this diagram a detailed overview of each task. My curriculum plan covering both coursework and research progress. I have successfully completed 2 optional and 2 main courses. In parallel, I've been involved in publishing 4 articles, 2 accepted and 2 under review. And also, I have obtained in Web of Science academic course certificate. And this is the key references that form the foundation of my research. As I mentioned before, my PhD research is supported by a scholarship under the mobilizing agenda of EXPAT. The first institution for this work is Added Lab in ITBC. Thank you for your attention, and I sincerely appreciate the support from the supervisors and HR and ITBC University throughout my research journey.
Thank you, Shadi. Congratulations, because I think you are the first one complete today, completely the first year of the PhD.
Yes.
Yeah. you are all the courses
Finished.
Yeah.
Already finished. Thank you very much.
You have a question?
Yeah. Shadi, let me use your first name because Mahmoud, it's more difficult. It's harder for me to say. You are collecting data, image data, and personal data, and you want somehow develop a system, distributed AI image-based localization for indoor industrial environments. How do you think to protect the data because of that? Because you know that there are very hard rules. European rules, Portuguese rules.
Yes.
You know that there are regulations to protect the data. How do you think to manage to protect this data?
Yes, and at first we didn't collect the data. We wanted to collect at first in the library, after that in the big industry. And for this part, we use federated learning because federated learning never show the raw data and just make a model and it give the model to others. So this is very privacy and it's very good. Because of this, we use federated learning.
And when you talk, when you put things like that, terms like that, edge AI, and even distributed, so you have to think about protection.
Yes, for sure.
You have to say how you will include it and somehow guarantee that the data, there are no leaks. So let me advise you, please, that you should be very aware of that and worry also. Okay?
About data. Yes, AI device is so secure, and because of this we use AI. In cloud-based method, there wasn't safe like AI. AI just everything is in the camera and in the edge, so It's so safe. Because of this, we use this method.
Good morning, everyone. My name is Pablo Fernando, and I'm a PhD student at UTAS. My PhD thesis project is optimizing energy efficiency in public buildings in the autonomous region of Madeira, implementing new measures and innovative technologies. And I'm working under the supervision of Professor Sérgio Leitão and Margarida Lopes at UTAS, and Engineer Fernando Silva, Head of Division at the Regional Energy Directorate of Madeira. I'm currently doing a professional internship at the Regional Energy Directorate of Madeira. The Directorate is a government institution in the region and makes decisive decisions in the field of energy. Nowadays, mitigating climate change and its impact requires efforts to reduce greenhouse gas emissions, the transition to renewable energy sources, and the application of the sustainable practices. Energy efficiency in public buildings is currently a major challenge. In order to increase energy efficiency, we must use energy resources responsibly and adopt measures to optimize energy performance in buildings, reducing energy waste and costs and maximizing energy performance, which in turn aims to promote sustainability. Global energy consumption in buildings exceeds 30% of the total final global energy use and contributes to 28% of worldwide greenhouse gas emissions. Therefore, implementing and innovate energy efficiency measures and technologies is an important step towards reducing energy consumption and decarbonizing public buildings. In order to reduce the energy consumption of public buildings, we must adopt measures or actions that help to reduce this effect. For example, utilize and use renewable energy applications for achieving energy saving buildings, identify the building's real energy performance by comparing energy consumption based on observations and computed energy modeling, adopting sustainable practices. With regard to increasing energy efficiency, you must review public policies on energy efficiency in buildings and use a model to describe the energy profile and explore various solutions to improve the efficiency of buildings. The main aim of my thesis project is essentially the application of innovative methods and technologies to optimize the energy efficiency of public buildings in Madeira, along with other important objectives for the development of my project, such as collating data on parameters that could influence improvement of energy efficiency in public buildings, implement a computational energy model that represents the energy systems in public buildings with the aim of analyzing their behavior and optimizing performance, and finally, present innovative energy efficiency measures and policies to be implemented in public buildings. The program is scheduled to last 3 years, divided into different stages. The first stage is research, bibliographic research, developer research, and innovation plan, which I am currently carrying out and which is scheduled to be completed this year. This stage will essentially focus on defining the plan to follow in order to achieve the desired objectives. The second stage will be the development of the energy model, divided into two parts. Firstly, data collection, and secondly, implementation of the energy model. In the final phase, I will validate and evaluate the results obtained. Finally, I will write the thesis and then defend it. With regard to the Sustainable Development Goals, the one that best fits my thesis is number 7, which aims to guarantee access to reliable, sustainable, and modern energy sources for all. Regarding the curricular plan, research theory and methodology was successfully completed, with the final certificate. The curricular unities. Option 1, electrical systems and energy maintenance. And option 2, complementary option, I haven't started yet, but I will soon. Teacher planning and scheduling 1 and 2, and the senior are in progress. The remaining curricular unities have not yet been started. Now, I am going to present the graphical abstract of my work. Buildings contribute significantly to CO2 emissions and consume a great deal of energy. Reducing energy consumption in buildings or changing energy use habits are important factors in controlling energy consumption. Change in behavior and values can have a positive influence on energy savings, contributing to the introduction of policies and reduce energy consumption. With this work, using computational energy modeling, I will carry out simulation of the main energy consuming systems and analysis of the results obtained from the energy model. Through this analysis, it will be possible to implement energy efficiency measures such as implementing new public policies that guarantee increasing efficiency, investing in more efficient technologies, optimizing thermal regulation and increasing the efficiency of HVAC systems, and increasing self-consumption of energy from renewable sources. Finally, all these measures to be implemented will have the main objective of promoting the reduction of CO2 emissions, lowering energy consumption, and increasing the energy efficiency of public buildings in Madeira. Thank you for your attention.
Thank you, Fabio. Thank you for your presentation. I have one question. Do you think to apply your methodology to all kind of public buildings or administrative building or sports building?
No, it's only administrative buildings.
Only for administrative buildings? At this stage, we have already defined what kind of frameworks or models you use to simulate the building behavior.
I haven't decided yet, but I will choose soon. But yeah.
Hello, Fab. Thank you for your presentation. My question is related to the one from Professor Batista. I understand that your work is very focused on administrative buildings, but it's also very focused on the region of Madeira. Is that for a specific reason? I understand that maybe your labs or experiments will be done in buildings in Madeira, but will not your model be scalable enough or applicable to be used to other buildings that are not in Madeira?
Posso responder em português, também é fácil para mim. Tipo, o modelo a aplicar neste caso poderá ser para edifícios administrativos, mas também poderá incluir, por exemplo, hospitais, escolas. Ou seja,
está mais focado na região, porque os padrões climáticos somos da Madeira, não é?
Sim.
Ou se pode ser escalado para outras regiões?
Não, só mesmo na região da Madeira.
Só vão ser dados e o modelo específico para a região da Madeira.
Exatamente, até porque os dados que eu já recolhi foram fornecidos a partir da empresa de eletricidade da Madeira. E já obtive os dados do consumo energético de cada um deles e a partir desse momento eu vou escolher os maiores consumidores e depois é que vou fazer a simulação desses mesmos dados.
Eu vou, agora, sem querer monopolizar antes, só mais uma vez não ficou muito claro, se calhar por deixo claro, ou pelo menos logo por bastante certeza, que é, pela apresentação que fizeste, eu não consigo perceber muito bem onde é que está a diferença do que vais fazer, porque já existe, um modelo de optimização da eficiência energética, num trabalho de doutoramento tens de colocar algum tipo de inovação aqui, mas eu não consigo perceber, tu já sabes, onde ela pode só depois de explorar melhor salário e vais conseguir identificar as
Sim, neste momento ainda estou a explorar no estado de arte, mas o objetivo é criar mesmo um modelo computacional e que possa servir de exemplo para outras regiões também, não só para a região autónoma da Madeira.
Hello, my name is Paul. I am a researcher at NSTech and currently developing my PhD thesis plan ITech mobile world food management and optimization at ILA, the Industry and Innovation Laboratory Network. This work is being developed with the support of my supervisors, Professor Pedro Costa from FIU, Professor Paulo Oliveira from UTAD, and Dr. Pedro Silveira, Senior Researcher at NSTech. Industry 4.0 demands flexible automated systems. AMRs are increasingly used in factory logistics due to their robustness and adaptability. This research begins with the homogeneous phase of two identical AMRs operating in a controlled environment, sharing the same mapping software. The focus is on developing an A-based path planner and a supervisor module for task assignment and real-time coordination. This setup enables accurate testing of planning efficiency, system robustness, and coordination strategies before scaling to heterogeneous and dynamic scenarios. While homogeneous fleets are useful for testing, real industrial settings involve heterogeneous AMRs, with differences in hardware, software, mobility, and roles. This introduces major coordination challenges, map inconsistencies, different motion models, proprietary navigation stacks, diverse sensor configurations. To address this, the research aims to build a scalable vendor-agnostic measurement system that enables shared mapping interpretation, unified task assignment, real-time conflict resolution. The goal is a flexible architecture capable of managing diverse robot fleets in dynamic, real-world factory environments. This research focuses on two main goals: develop a centralized fleet manager for heterogeneous AMRs capable of coordinating diverse robot types, tuggers, forklifts, carriers from multiple vendors with different motion models and navigation systems, and enable interoperability through standardized communications using PDA 50/50 over MPPT to allow seamless task delegation, real-time status updates, centralized fleet control. These objectives aim to deliver a flexible vendor-agnostic system fit for all real-world industrial environments. This slide highlights two core components of the fleet management: the map management and conflict resolution, responsible of merging different local maps into a shared global view, using graph-based models to detect and resolve special temporal conflicts, example two robots crossing paths at the same time, and the intelligent task-to-robot assignment that match tasks based on robot type, availability, route feasibility, and cost efficiency, energy, time, or other parameters, and ensures each task is handled by the most suitable robot, improving fleet performance. Together, these modules enable coordinated, optimized, real-time fleet management across heterogeneous robots. This part of the research focuses on adding the time dimension to planning and enabling real-time fleet supervision. First, we will enhance the traditional style algorithm into a time extended as time. This lets us plan not only where a robot goes, but also when it gets there, helping avoid collisions and improving the overall flow. Next, a real-time supervisor module will be developed. It will continuously monitor robot movement, trigger replanning when disruption occurs, manage priorities between tasks and robots, and ensure safety and smooth operation on the factory floor. Finally, we will validate the complete system in real industrial environments involving multiple robot types and constant high dynamic flows. This is key to proving the system can scale, adapt, and perform reliably outside the lab. The graphical abstract illustrates the evolution of the research. On the left side, the starting point, the homogeneous setup with two identical AMRs, a shared map, a centralized coordination. It's a simplified environment used for initial testing and validation. On the right side, the target scenario, a heterogeneous fleet of three different robot types, each with its own map, graph, and navigation logic, mirroring real industrial complexity. The system analyzes and aligns this diverse representation, enables conflict-free coexistence in the same environment, and perform real-time optimization of task allocation, resource use, trajectory planning, safety, and cost. This transition reflects the thesis goal to develop a scalable adaptive fleet manager ready for complex and industrial sectors. The work for 2025 is divided into two tasks. Task 5, the simulation stage, which breaks the trajectory and map manager and the task and resource manager into the IMR simulation scenario, using the heterogeneous EMR tool. Adjust core algorithms like the enhanced path planner and the supervisor to support this integration, and perform extensive testing and validation to ensure everything works as expected. The task 6, real deployment. Set up a real heterogeneous robot fleet in the AI lab, deploy the validating modules in the real-world lab environment, conduct final validation under realistic industrial conditions, and continue with the thesis writing, now backed by real-world data. Finally, the work leads to the final thesis publication focused on the heterogeneous fleet management. This slide shows a short video illustration of the state simulation environment, where you can see a map of ILR with a fleet of 6 homogeneous robots, each with its own characteristics and color. At the same time, the same environment and the trajectories of all robots can be visualized in RVs. As already mentioned, the aim is to have several robots within the same space, but with different trajectories and tasks. In the end, we see robots' trajectories all overlapping, and it's up to the trajectory manager to identify all these conflicts and pass the information onto the pipeline. As is possible to see, we are launched every robot's trajectory one by one, and here you can see all the trajectories overlapping. The curricular component of the PhD is progressing well, with most foundational and optimal modules already completed. This is the references. Thank you for watching and listening.
You already finished the first year completely today.
Yes, the first and the second and the third. I want to submit my final thesis until November.
Oh, it's already done.
Some modules, yes, and I'm in the test phase. And after that, I want to finish the written of the thesis and send it.
Where do you apply first time?
My first year was in 2019, but I'm a researcher in ECE Tech, so I had to work in some projects, internal and European projects, and now our team, it's more bigger, and now I have my time to finish the thesis.
You are working in design?
No, in ECE Tech, ILR.
Congratulations for your work, it's a very nice work. Since you are almost at the end of your work, as you mentioned, can you share with us what were the biggest challenges that you had, since your problem is a rather complex problem, you are not just optimizing the routes of one vehicle, but of a fleet of them?
Yes.
So what was the biggest challenge for you?
The first challenge is the fusion of the different maps of the robots, because every robot has its own map, getting by the aid of the laser on its platform. So the fusion of the different maps to get one map for all robots, it's a big problem, and we use a matching of coordinates of the environment to overlap the old maps. That was the first problem. The second one was getting the data from different vendors. In these scenarios, laboratory scenarios, we will use one Omron robot, AMR, and another AMR from Flobotic, that is a Portuguese company that developed AMRs, and more 5 AMRs developed by us on the laboratory. So to get the data from the other AMRs from the other companies, it was difficult, but with the integration of the VDA 5050, this framework allows or enables to get the information about the AMR's characteristics, like navigation types, dimensions, protocols, communication protocols, and another characteristic. So that was another problem that we resolved, and now we are developing a task and resource manager to get the tasks from the mesh or ERP, and then convert and then analyze that tasks to send to the best available robot for that task type. So we get some big problems, but with our team and the knowledge of the center, we could get the best results.
The problems are good for us as researchers, right? Because they give us the opportunity to
Yes.
I'm João Castro, and I'm taking my PhD in electrical and computer engineering, with the proposed title for my thesis, growth harvesting using modular robotics. For the development of this thesis, I count on the support of my supervisors, Dr. José Boaventura, Dr. Felipe Santos, and Dr. Mario Pinto. So on to the introduction. So, grapes are the most widely grown commercial food crop in the world, and also one of the most popular food crops for horticultural production, with producers constantly searching for new ways to maximize their profits in this activity. But what is the importance of grape harvesting? Grape harvesting is a critical step in viticulture that directly influences the quality and characteristics of the wine produced. The timing and method of the harvest can determine the sugar content, acidity, tannin levels, and the aromatic profile of the grapes. In terms of robotics, with an increase in world population and a decrease in agricultural labor availability associated to strict time constraints dictated by the optimal harvest window, the motivation for research of robotics in the agricultural field has increased. So, in this PhD, the solution we propose for these problems is a robotic grape harvester using advanced sensing and different tools to enhance the grape harvesting process while protecting the grape integrity at a low cost. So, the main research questions we present are the following. The first question is, what are the main challenges of manual and robotic grape harvesting? Meaning, what are some of the obstacles that not only the field of robotics, but also the producers might find in this environment? The second question is, what is the impact on the productivity of grape harvesting using different methodologies to acquire the grapes? The last question is, will it be possible to assist or replace manual intervention while overcoming biases toward robotic solutions in the agricultural context and successfully transferring agronomic knowledge? So we not only want to bring these solutions to life, but also integrate the producers and teach them the same way they will teach us regarding this area of expertise. So with this being said, the three main goals are the review and definition of requirements for robotic grape harvesting, the study, development and testing of computer vision algorithms and perception systems, and finally the design and validation of different tool methodologies. So the first research topic that will be approached is computer vision and different perception systems that can be used for grape detection. These perception systems we can use cameras or maybe radars as well, because in specific cases we might have some occlusions in the vineyard and the detection might be done based on the presence of liquids in certain areas. The tool design is also very important in order to understand the impact of the robot in the plant and the food itself. And right now in the literature, we have
a lot of scissor-based solutions, but we also want to explore laser and thermal-based solutions in this context. And finally, we have the control systems to guide the manipulator with precision. This can be done with various methods, such as proportional integral derivative controllers, model predictive control, and right now there are some approaches that use reinforcement learning, so multiple ways that this can be done, and we intend to optimize this process. In terms of schedule, the two curricular units that I have chosen are microsensors and microactuators, and the second one is image processing and computer vision, with 2 articles already in progress. Research theory and methodology and thesis planning and scheduling 1 are already complete. So this is the proposed Gantt chart that we have proposed for the development of this thesis that can be divided in several different work packages. So the first work package is the review and definition of the requirements for robotic grape harvesting, where we'll have initially the technical functional requirements of the system, but also the cost effectiveness and relevance that we intend to understand by interviewing several different producers. Second work package is the study and development of perception systems, where we first have the dataset collection of grapes, and then we have the development of deep learning models and radar-based systems. In the third work package, we have the tool design and validation, where initially we'll have the tool conceptualization and the development of a manipulator-based system, where here we intend to preserve the grape integrity. We'll also have the development of a mechanical vibration system and the system integration and validation finally. The final work package is dedicated to scientific dissemination and thesis development, where we'll have the dissemination of the results through scientific papers and also the thesis writing. Finally, we have the graphical abstract, where we propose the use of advanced perception systems, such as radars and cameras, to be able to detect and identify the grapes. And with this information, it allows us to control the manipulator with a tool associated, of course, and this tool can be a scissor, a laser-based solution, a thermal-based solution, to efficiently do the grape harvesting itself. Thank you very much.
Thank you, João, for your presentation. I have a question. This work is framed in some kind of project or some kind of course?
I'm currently at Ineshtec. I'm not sure right now in what specific project it is inserted, but yes, it's in a specific project. But I don't know what it is.
How this idea comes to this topic?
Yeah, so
Where did you find it?
yeah, so we work very tightly with agriculture and robotics, and we always had this idea of developing a grape harvesting. This idea also came with the help of Professor Mario Cunha from school, and it was just a question of timings, and this was the year where we had to develop a grape harvester in our roadmap.
João, do you have an idea of what kind of data sets that you will be using for the identification of the grapes, the bunches of grapes, the kind of the place where you cut?
Yes. So we intend to do these tests on the Douro region and also in the Verde region, if I can call it that.
Yeah.
But yes, the detection is already a big challenge because, as I said, we might have some occlusions due to the leaves. Yeah, some.
Let's be nice. Some.
Yeah, some. But yes, we might use those radar-based systems, as I talked, that might detect the presence of liquids. So we might not have the image and know that there's a grape, but through the presence of liquids, we can estimate where it will be, or at least we know that there's a grape bunch there.
On that point, could it assist humans rather than robots at the first stage?
Sorry?
At the first stage, before you get to robots, could it assist humans in being better pickers?
Yes, at least it can give the humans
Data.
exactly an estimate of the production. We might have like a map, a heat map with the grape bunches and where we can detect it.
To plan the workforce, to plan the assets,
Yes,
to
yes.
do the workforce planning, to see the optimal route of the grape picking.
Yes.
And the timing.
Yes, yes. We are also studying some options regarding. These are not the optimal options, but in vineyards where people have already cut the leaves off and we have like perfect images, we of course don't want to do this because we want to keep the vineyard integrity, but it also might be an option.
Do you have an idea of the kind of grapes that you are picking, and that is, how can I say it? I've done it some work of that in this field myself,
Mm-hmm.
and I know that there are different kind of problems and difficulties associated with
Yes.
identification, depending on the kind of grapes. If they are dark grapes or red grapes, if they are white, etc. But imagine a robot,
Mm-hmm.
and you don't need to travel long. Just go outside and see this vineyard here that it's called Maria Teresa.
Yes. Yes.
This is the vine, Maria Teresa. So you can, if you can see the climate there, how can you put the robot to pick up?
I'm not in charge of that mechanical part, but yes, I assume I'm in charge of the perception part. But I understand that is a major challenge as well.
You don't think of what other kind of models besides the AI models. You don't think, because sometimes you don't have to use an atomic bomb to kill a fly.
Yes.
You know?
Yes. No, I understand that. We're also testing. It's initial phase, but we're also testing with cameras that have like point clouds. And right now, one of our ideas is like we can have an estimate of the dimension of the grape bunch. It's just an estimate. And right now, a big challenge as well is to know where to cut the pedunculus. I don't know if that's the right word, but we can, using that point cloud, if we know there's a grape bunch there and we have an estimate, we know where those specific points of the point cloud should be to know where to cut the grape bunch. So I think that's a place to start this research in terms of.
Let me only just congratulate you for your courage and wish you good luck for your.
Hello everyone, my name is Daniel Fernandes. I am a PhD student and a research fellow in the Forward project. The title of my thesis is A Model for Human-Robot Collaboration in Viticulture, and my supervisors are Professor Fabian Schwartz, Professor Antonio Valente, and Dr. Guilherme Alves. I'm going to start to talk about AI for Work project. AI for Work is a project that focuses on how people and AI systems can collaborate at work. This project is financially and institutionally supported by the European Commission under the Horizon Europe Research and Innovation Framework. This project has 6 pilots: healthcare, agriculture, this is our pilot, agriculture pilot, manufacturing, construction, education, and logistics. These pilots deploy human-centric AI systems across various sectors, with each pilot focusing on a specific domain and addressing multiple relevant use cases within that context. To ensure that AI solutions are safe, effective, and accepted by users, AI for Work is used an evaluation in different categories: technical, operational, and social dimension. Technical measures system accuracy, reliability, and scalability. Operational evaluate productivity, cost effectiveness, and environmental performance. And social dimension is about well-being, fairness, privacy, job satisfaction, and trust in AI. Human-robot collaboration has gained significant relevance in recent years due to the positive impact it can have on our society. It's a topic that involves the study, design and implementation of systems and interfaces that, with the advancements in deep learning methods, enable effective communication and collaboration between humans and robots. This project takes the advancements in AI, data and robotics experience to working conditions in Green. Working on Green is not an easy job. Consists in a physical job where the workers are exposed during a lot of time to difficult conditions, like hot weather, working on steep terrain. So those factors turn to work more difficult and less efficient. So this project motivates me to work on enhancing working conditions through innovative technology. The objectives of this project are aligned with the objectives of the pilot number 5 in AI for Work, with agriculture pilots. Monitoring worker fatigue. The goal is to enhance workers' fatigue management by using AI technology that will analyze data to identify fatigue trends and suggest task adjustments. Identification of critical vineyard locations. It's a priority to identify areas based on data and looking for key risk factors, such as steep slopes, disease risk, and soil weaknesses. Transport of the grapes in vineyard during the harvest season. This is a task that involves a big physical effort from workers, so the objective is with AI technology implemented on drones, using them to make the transport of the grapes to improve efficiency, reduce physical demand, and ensure grapes quality during this task. I'm going to show a quick video that shows our goal in this topic, the transport of the grapes. Of course, this is an AI video, but anyway, we can see the objective. So here's a drone transporting the chest with grapes. And the last objective, create an environment of working shared by human and robot. This concept is called slave work sharing and consists of making the management of which tasks are made by the human or made by the robot, associating them appropriately to turn the job more efficient and safer for you. Doing all of this, the project is also aligned with two sustainable development goals of United Nations, industry, innovation and infrastructure, and partnership for the goals. About methodology, to ensure responsible AI deployment, each AI for Work pilot will follow a methodology that bridges research and reality, ensuring practical value and measurable impact. We start with scenario planning. This topic involves creating the project plan, starting with a study in different technological areas to develop solutions to the defined objectives. For example, study machine learning algorithms, shows technological equipment. So at this stage it's important to select the best technological equipment to be used for the project. The robot chosen in this project is a drone, is the most practical and appropriate to make the vineyard tasks, and wearable devices like those represented on the pictures in this slide. The wearable devices to track worker fatigue, allowing AI to analyze fatigue trends. Then web prototyping. In this part should be developed and tested the prototype of what is going to be implemented during the project. The purpose is to validate before exposing the system to real world. For example, create a digital twin prototype to simulate great transport scenarios. So that way we can simulate and preview how we are going to implement this task on the field. And then field deployment. The purpose is to observe how AI performs when implemented on the field. And in this step it's important to make some tests, like select and test cargo drone for grape transport, and the workers will test the wearable devices. And in the end, feedback and refinement. In this topic will be made a review of the results. The feedback from the workers is also really important for us to make conclusions about the impact of this human-robot collaboration. and make adjustments and improvements. Here's the schedule. In the first year, development of curricular units and submission of thesis planning. In the second year, conclusion of curricular units and start of thesis development. And in the last year, continue the thesis development and we'll finish this part. Here's my curricular plan, requiring a certificate, and the graphical abstract. Here's an image that shows the drone transporting the chest with grapes, and then I create a graphical representation that shows the interaction between human and technology. So the wearable devices and the drones are collecting data from the human worker activity. The drone is also collecting data from the vineyard. For example, taking pictures to the plants and the leaves of the plants. And then we have an AI system, sliding work sharing management, and this system will analyze all the data. So, for example, imagine that the system detects that the worker is static and is no longer safe for him to continue a specific task. The system will send a message to wearable devices on drone. The wearable devices will notify the human to stop working or change to another task, and the drone will take his place and finish that task. So, thank you for your attention, and if you have any questions, I'm here to answer them.
Thank you, Daniel. I have only small question. Well, your work, your topic is very close to the topic of João. João makes the grape harvesting and you make the grape transportation.
Yeah, made by drones.
The vineyards are completely autonomous.
They are only needed for drinking. That's great, that's great. That's great.
The robots not drinking.
Yeah, the robots will not work.
Is this work framed in some kind of project or some kind of scholarship?
Sorry,
this work, this PhD is framed in a
AI for work.
You are researching this project?
Yes, I am a researcher.
What is your task in the project?
My task is I am a researcher in AI for Work project, and AI for Work is this objective to implement AI collaborate with the humans.
You are working at that?
Yes, yes.
Okay. So, but your work is to fully to turn it fully automated the flight of the drones.
Right now, I'm just thinking in how the drone will actuate and connect with humans' work. But yes, the objective is to drone will.
I'm just asking that because I got confused when you said during your presentation that the drone is collecting pictures and automatically the system will alert if there is needed for another action there, if the worker is fatigued and needs to be changed to have some rest, etc. So I don't really understand what the focus of your work will be.
The drone is always taking the pictures and the information from the vineyard.
Yeah.
But when the system notifies the drone to substitute the humans, so the drone will actuate in this time.
So your work will focus on the control of the drone.
And the AI system, when the system will detect that the worker is fatigued.
also the AI system. You
Yes.
have to analyze the,
Yeah, this is,
for example,
this
the
is the
image.
most important part.
Okay.
Yes. Not only the drone, but also.
You have a question? Yes. Does that include the wearable part? You are getting information from the people from the wearables, right?
Yes, yes. The
Is that
data.
already developed, or is it also part of your work?
I am using wearables that are already developed. Yes.
But are they closed already? So the wearables that you are going to use in this project, they are already identified, you are not going to change them anymore? Or is it
Yes, yes.
still open?
The wearables.
I'm asking this because I believe this is an important issue when we are talking about the physical work. The workers are there the whole day working, catching the breaks. And if it is something that is discomfortable or something that is heavy, it will affect their workers' performance. Right? So I think it is also important not only to look at the functionalities of the wearable, if they are able to communicate, to sense whatever they need, but also if they are comfortable, if they are suitable to be wear all day.
Yes. This is
last all day or not?
This is an important topic. That's because I referred in methodology in the last step, feedback and refinement, I think. In that step, it's important to understand feedback from the workers. So in that step, the workers will send us information if they feel comfortable with using the wearables. That's it. So good afternoon, everybody again. I think it's going to be obvious what the research is going to be about. No, smart irrigation management for improving water productivity under climate change. As my supervisors, I have Professor Antonio Valente, Professor Salviano, and an external professor from the University of North in Croatia, Dr. Sasha Peter. This project is done under the supervision or the support of the previous company that I represented. Now I'm the student. The motivation is more than obvious. Advancing precision agriculture, real-world case study, and you'll see that on the gap analysis, why we need actually to look at something that is on the ground and actually working. Early issue detection of problems in the farms, data-driven optimization, sustainability and impact, and scalable for insights and the applicability on other cultures and other farming. Through the gap analysis, integrated data analysis, so there is limited research on the field in terms of real case studies. There is a lot of research done in the lab, done in small aspects, but nothing in terms of great scale. This is going to be a case study that will apply data of over 2 years. When I actually start writing the thesis, I will have 2 years of data already ready to be sliced and diced. Currently, there's already 1 year and a half of data. Irrigation system diagnosis, there is a lack of research using a combination of sensors and understanding if one sensor is giving you that data, that other sensor is giving a completely different data, what's going on. And that's exactly what we are seeing on the ground. It can scale to the real world, while most of the research that I've read so far, they are limited to academic research, low scale, a few devices here and there just to collect data, and that's it. And then the economic and environmental impact, the research rarely quantifies what is the value in terms of economic that brings actually into the field. Those were the gaps that are very clear in all the papers that I've read so far. The objectives are to evaluate the effectiveness of integrating sensors into the system, analyzing data to identify irrigation inefficiencies, develop a decision support model for irrigation management, assess the impact of smart irrigation and, above all, water management, and correlate soil health with crops performance. That's the data that is being collected at the moment. and then explore the scalability of a system like that, not only on the blueberry system or blueberry farms where this is going to be applied, but as well on other crops, on other cultures that exist currently, not only here but in the world. The schedule, so currently I'm finalizing the curricular units, and they will be concluded by this year, and I'll start actually already writing the thesis, hopefully after the summer, when I have very rich data after a very hot summer like it was last year. So the plan is actually to complete by next year. Research theory and methodology are complete. I'm waiting on Professor Valente actually to own clarinet and press the button. Option 1 and option 2 are in progress at the moment. Some of the articles are already in progress of being writing. Thesis planning 1 and 2 are complete, and the seminar will be complete today. And the graphical abstract, you know, 2 pictures that are in there already that you've seen in the morning. The plan is exactly to bring what is currently being used in the ground with open source software that can be easily applied, and then slice and dice all that data to come to proper conclusions and to come to a solution that can be easily applied into the ground. And then some references for you if you want to start reading. There's many more than this. These are just a very low summary. That's it. Thank you. Questions?
One
I have a small question, a small suggestion for you. You must put in your model as input variable the price crop in the market.
The price?
Yes, because in the morning you said
that's the plan.
Price increase with the weight.
With the weight. No, not just with the weight, by the way. Because, for example, blueberries, they start cropping, they started around a month ago. Those are very expensive. Now they are very cheap. And the September ones are again very expensive.
So in that case,
you actually have a curve depending on the type of plant that they have. This farm actually has 4 types of plants. So they crop from July until September. They are always getting their blueberries from the ground. And that's exactly what it does.
Can I ask you?
Yes, of course.
Having looked at the last 3 projects,
Mm-hmm.
you see multimodal data.
Yes.
Yeah? I'm interested, you have the foundational data. You have the foundational and the geospatial.
Yes.
So how do you all work together?
That would be my third PhD going forward. For now, I have enough.
Everyone's doing work on this vineyard or in this area.
This is not vineyard, this is blueberries.
Okay, but it could be used for other things.
Yes, one of the ideas that is still being thought at the moment, probably will go ahead, is actually to plant some cameras on the ground and actually correlate the data that we are getting from the underground with the aspect of the plant. So do that correlation so that the farmer actually, because the farmer doesn't see below ground, but they actually look at the plant, and if they know exactly what they should be looking when they look at the plant, they'll know, or there will be a correlation of data. If the leaf is like that, that means that underground something is happening.
Okay, I'm probably looking at farmers because of the data. Who else would be interested in the data you produce?
Yeah.
That's my...
Currently I have loads of data, and I'm happy to share that data with whoever wants to actually explore it. More than happy, so just give me a call and feel free. I have billions and billions of rows of data at the moment. Just for this farm.
The infrastructure, how you're collecting that. That's the interesting part.
It's already on the ground. So it's collecting at the moment, so there's 13 sensors on the ground, collecting data every 5 minutes, sending data from the flow meters every 5 minutes. We have around, on a monthly basis, 550,000 communications on that single farm. Yes. Yeah, okay.
We will need your contact. And you want to have a thesis in there.
No.
If you give us your data, Don't have the thesis anymore.
I can lend you my data, I won't give you my data.
Yeah, but if you lend it, it's like giving.